Welcome to this presentation on the concepts of atoms, molecules, and ions. In this session, we'll explore their roles in chemistry and their significance in understanding the nature of matter. Atoms are the smallest units of matter that retain the properties of an element. Each atom contains a dense nucleus made up of positively charged protons and neutral neutrons, surrounded by negatively charged electrons that orbit in defined energy levels. The atomic number identifies the element, while the mass number provides the total count of protons and neutrons, essential for distinguishing isotopes of the same element. When atoms chemically bond together, they form molecules. These bonds are primarily covalent, where atoms share electrons, or ionic, where electrons are transferred. For instance, oxygen forms a molecule by sharing electrons, while water molecules consist of covalent bonds between hydrogen and oxygen. Understanding molecular structures helps explain the behavior and properties of substances. Ions are particles that carry a net electrical charge due to the loss or gain of electrons. A cation is a positively charged ion that results when an atom loses electrons, commonly seen in metals. Conversely, an anion is a negatively charged ion that forms when an atom gains electrons, a characteristic of nonmetals. Ions play a crucial role in forming ionic compounds and in many biological and chemical processes. In the earliest day of the development of atom, there are many scientists that contributed immensely. We will be looking at this scientist and their contributions. John Dalton is celebrated as the father of atomic theory, proposing in 1803 that atoms are indivisible and form the basis of all matter. He stated that atoms of a specific element are identical, while compounds result from combinations of different atoms. His revolutionary ideas laid the foundation for modern chemistry, transforming our understanding of matter's structure and behavior. Robert Millikan's groundbreaking oil drop experiment in 1909 measured the exact charge of an electron, a discovery that refined our comprehension of subatomic particles. In the same era, Ernest Rutherford conducted his gold foil experiment, revealing that atoms have a small, dense nucleus surrounded by vast empty space. This discovery revolutionized the atomic model, shifting away from the plum pudding model. Henry Moseley's research in 1913 demonstrated that an element's atomic number, rather than its atomic mass, determines its identity, resolving inconsistencies in the periodic table. Decades earlier, J.J. Thomson had discovered the electron, proposing a plum pudding model where electrons were embedded in a positively charged sphere. While later disproved, this model advanced the study of atomic structure significantly. Niels Bohr introduced the concept of discrete energy levels for electrons in 1913, explaining how electrons orbit the nucleus without collapsing into it. His model described how electrons absorb or emit energy when transitioning between these levels, providing a quantum basis for understanding atomic stability and spectral emissions. In conclusion, atoms, molecules, and ions are essential components of chemistry, shaping the properties and behaviors of matter. The contributions of early scientists such as Dalton, Millikan, Rutherford, Moseley, Thomson, and Bohr provided foundational insights that continue to guide scientific discovery today. Thanks for watching. To deepen your understanding of SI units, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concepts effectively and enjoyably.